Today we will talk about a natural disaster called volcano. Last time we were talking about the earthquakes, and today we will learn some fundamentals about volcanoes. Let's start. Uh, to know about volcano and volcanism, we need to know some definitions at the beginning. So the first definition is the process uh, of volcanism. And the volcanism is a movement of magma. You know, the magma is in the magma chamber. The movement of the magma through the crust, and it emerges as a lava. So inside the earth called magma. Once it goes outside the earth's crust, we call it lava. And volcano is an opening in the crust through which this molten lava or this molten magma comes out, and rock particles reach the surface and pile up. Pile up means creating like mountains. And a volcanic mountain, it is built by the successive volcanic materials, and in the same time also we call it volcano. And you can see that from the picture outside this on the right of this slide. You see how the magma is coming out of the earth in the form of lava. And volcano can be active or dormant or extinct. Active, we call it active if it is still erupting, and we call it dormant between the durations or between the eruptions. I mean, if the volcano is volcano is erupted already, and between eruption and eruption, we call that volcano is a dormant volcano. And we call it extinct if it is no longer erupting, if it is cold, if it is stopping. So some of those extinct volcanoes are eroded by the erosion factors. So the remains only of this volcano, we call it volcano necks or volcano neck, and the plural is the necks. As you can see from those two figures, these are volcano necks. And the volcano neck is a solidified magma from inside the volcano. And good examples of the volcano necks are Devil Tower and Chimp Rock in New Mexico. Most of the world's active volcanoes, active ones now, okay, are found along the rim of the Pacific Oceans. And this area we call it major earthquake zones, and also we call it a rim of fire or ring of fire. As you can see here, around the Pacific Oceans, all these red dots. Okay, so the curving belt of active faults and volcanoes is often called a ring of fire. It is the largest plate boundary with the most plate interactions. Now we come to the components of any volcano. The top part of the volcano, where is like a bowl-shaped depression, we call it crater. So it's curved down, called crater. And inside the crater, there's an opening. Within this crater, we see an opening called vent. The vent of dormant, of course, volcano is usually blocked because it's a dormant. Dormant means between eruptions. So in this case, we call it the vent. We know that the vent is closed or blocked by a thin layer of solidified lava. until the next eruption, of course. When the molten lava inside the volcano builds up and there is enough pressure to push it up, the molten rock breaks through this solidified area, and the volcano erupts again and become an active volcano. As you can see from the figure on the right, how volcano works, you see the crater and you see the lava flow after it comes out, and layers of ash, like precipitating or accumulating around the cone of the volcano, and the main vent is down, and you can see also some side vents. If you have any fissures or fractures in the earth, you will see more vents from the side. And down is our magma chamber. Now we come to the types of volcanoes or volcanic mountains. There are three types of volcanic mountains or volcanoes. We call them shield, cinder cones, and composite volcanoes. They differ in size, they have different sizes, shapes, and they are also different in the way they are formed. The first thing that we will learn now about is shield volcano, and you can see from the figure here the magma is pushed up through the cones of the volcano and create the shield volcano, which is like a large one. Shield volcanoes, they happen or occur at divergent boundaries of plates and hotspots. When the lava comes out from the vent, they flow until they cool down and harden into rocks. And the lava is able to flow smoothly because it is basaltic lava. And keep that in mind. If the lava is able to flow smoothly, it is a basaltic lava, because basaltic lava is low in silica and high in iron and magnesium, which make it very fluid. Second type, still we will talk also still on shield volcanoes. Those lavas have like a little gas or water vapor trapped in basaltic magma, and you can see how they flow very smoothly. You can see very nice picture of a volcano, which is a shield volcano, and they built a massive mountain with gentle slopes, not steep slopes. We call them shield volcano. Okay, so they cover large area. They are the largest volcanic mountains regarding to the area. And examples of that, Mauna Loa and Mauna Kea are the largest, and they make up the island of Hawaii. Both of those shield volcanoes, they rise up to the height of 10 kilometers of the ocean floor. They reach more than 4 kilometers above the sea level. Okay. The second type is called cinder cones. And cinder cones, from their name, you can just say they are cones, simply very small and cones, and they generally occur at hotspots. And they are explosive eruptions. Lava is like hurled high in the sky into the air, and they spray at droplets of various sizes. Those droplets cool down and harden into a cinder and particles of ash before falling to the ground. And those ashes and cinders pile up also around the volcanic vent to form steep, be careful here, steep cone-shaped hill called a cinder cone. So this is the major difference between this type and the type before, which is a shield volcano. Here it is steep, cone shaped, and they don't cover large areas like the shield volcanoes. The cinder cones eruptions are explosive. Why they are explosive here? They don't move smoothly like the shield volcano, because the lava here is granitic. The lava is granitic in composition, and granitic lava contains a lot of silica and gases and water vapor, which makes it like a very thick and always under pressure. That's why they are explosive. Cinder cones are relatively smaller volcanoes, and their height is around like 500 meters. And cinder cones may form quite rapidly. The third type is composite volcanoes, and from their name they are like they have more than one type. Form at convergent boundaries, not divergent. At subduction zones, you know where the subduction zones, where the oceanic crust sinks underneath the continental crust, and lava here is rhyolitic and andesitic in composition, and this material collect a lot of gas and water vapor, which makes the eruptions quite explosive. As you can see from the figure here, you have the crater, you have the lava flows, and there is a composite volcanoes because they have more than a component here. Yes, they built up by both lava flows and ash and cinders. Okay, the last type, with the third type, is composite volcanoes. Still, we know about this type of volcano, as they are not as big as a shield volcano, but not big, not large. They are huge but not large in area. Composite volcanoes are generally much larger than the cinder cones. So what type is the smallest type here? The cinder cones. Good. And the largest type in area is a shield volcano, and the huge one is a composite volcano. Okay, and this picture represents the composite volcano, and many volcanoes of this type are famous because of their cone shape, peaks, and powerful and explosive eruptions. And some examples of this type are Mount Fuji in Japan and Mount Vesuvius in Italy. And this is a summary of our three types of volcanoes: shield, cinder cone, and composite volcano. And shield, gentle or non-explosive eruptions of flowing lava, and they are widest, means in area, large. The second part is most violent, the cinder cone, because it's explosive, and they are smallest type. And for the last type is explosive or non-explosive eruptions, and they are biggest ones. And this is enough for today, and inshallah next lecture we will talk about a new topic in our physical geology class. See you then. Bye.